I have 3 concept questions I want to go through. These are all related to capacitors in some way. Sorry, I did write capacitors. My computer's just having some issues. Now, one concept question that I've already covered was in the capacitor example problem 4. If you have not watched that one yet, make sure you test yourself on that concept one. I put it as an example so that I could also ask another question with it for practice, but I do approach the question initially as a concept question, meaning I show you the question and ask you to pause and determine your answer, and then watch the solution. So our first question here, right here, what do you think is the answer? The correct answer here is A. Now, it is true that we can solve for capacitance in our equation that has charge and potential difference. I'm waiting for my V to show up. There we go. So this equation is a wonderful relationship, but neither C nor delta V actually can change the capacitance. C is always determined by its construction, essentially, how it was made. If you remember, for a parallel plate capacitor, I'm going to go ahead and put the dielectric constant on here. It would depend upon the material between the plates. This is the dielectric constant. I'm trying to write that, but my computer is not. I'm overworking it. Anyway, capacitance depends upon the dielectric constant, the cross-sectional area, and the distance between the plates. If we don't change the area of the plates, the distance between the plates, or the material inside the plates, we do not change the capacitance. So even though C we can solve for knowing Q and delta V, Q and delta V do not determine C. Here is our second question. Let me get that up here. What do you think the answer is? Okay, the correct answer is A. There we go. Now, it is true that the equation we directly have in the test notes for potential energy of a capacitor is 1/2 C delta V for the capacitor squared. But I don't want to leave it this way, because we are obviously changing the capacitance. because we are increasing the distance between the plates. But if we change capacitance, we know capacitance is determined by the cross-sectional area and distance, but it is also directly related to the charge and potential difference. And so if capacitance changes, then either charge or potential difference, or even both, must change as well. In this particular question, they're telling me that Q is not going to change. It cannot change. So what I'm going to do is I'm going to say delta V is Q over C. And I'm going to put Q over C in our energy equation so that I write our energy equation in terms of Q, which is not changing, and C, which is changing. So now when I write my energy in terms of just these two, I know Q's not changing. All I care about now is what's happening to C. C is epsilon naught A over D. If D increases, then C decreases, since D is in the denominator. So our capacitance is decreasing. That is in the denominator now when we've written the energy in terms of charge and capacitance. So if C goes down, energy goes up. So anytime I'm trying to relate pieces of an element like a capacitor, I try to write my equation in a way that it's in terms of only one thing that's changing. And then I don't have to try to think too hard about how, in this case, potential difference is changing while C is changing. Though that is totally doable if we want. Let's look at one more concept question. So what do you think the answer here is? The correct answer is B. These are in series simply because I don't have a battery to follow a path from, but I can start my path on the left and go to the right, for example. When I do that, I have to pass through both of these capacitors. That's what puts them in series, or that's what means they are connected in series, I should say. So 1 over 3 plus 1 over 6 is 1 over C equivalent. If I get a common denominator, this adds up to be 3 over 6, or 1/2. But this is equal to 1 over C equivalent. So I need to flip that. I get 2. The units are going to be the same as the units that were on our original capacitor. So the 2 microfarads.